Today we're going to be working on the 1936 Chevy Truck again. Here is the front fender for it, and the goal for today is to get this patch panel that we fabricated welded in to the fender. Alright, well, just to get everybody caught up here on the same page, we're going to take a little journey back in time here to just over a year ago when my beloved smoking jacket was still largely intact and the chicken truck was still just a twinkle in mine eye. Anyways, we're going to show just a quick overview of how I built the patch panel for this fender. So I started out by making a paper template. Now I am going to put a link in the description to the original video on fabricating this patch panel. It goes into the process in a lot more detail. This is just a quick overview to get everybody caught up, and it enables me to phone it in a little bit and reuse some old content. So there you go. Once I was happy with the way the paper template was fitting, I transferred that over to a piece of steel 18 gauge, and then we began tuck shrinking the edge. That's a process where I put a series of ruffles into the panel, and then I go over to a stump and I hammer those ruffles flat, which therefore shrinks the metal. And this is long before I bought the tucking hammer from that character over at Make It Custom, so we had to do this the primitive way, which does work, but the tucking hammer from Make It Custom does this job quite a bit more efficiently and whatever. So anyways, we struggled through it and we did manage to make our tools work. And here's a cat. This is Poe, and Alan is in the background. I just thought that was really important to include. And we had to repeat the tucking process several times in order to put enough shrink in the panel. This is kind of an old school way of doing it without using any fancy tools. But again, it does get the job done if you're patient. And here's just another look at that tucking process. There are a lot of different ways to do this. This is just kind of what works for me, I guess. And crude and whatever, but like I said, it does get the job done to some extent eventually. So as I was hammering on this, I was constantly rechecking it to my paper template. I went on and on and on about this in the original video, about the importance of that, but it really is important. And here I am adding some stretch to the center of the panel, again just using a mallet and sandbag, and having paper templates and profile gauges of the panel we're trying to make is extremely important with this type of work. Otherwise, we're basically just hammering on the metal without any sense of direction. And you will get to something eventually, but the paper template just makes it so much easier. And here we are getting ready to wheel out and smooth out all the lumps and bumps. This is just basically a cheap English wheel from Harbor Freight or Princess Auto if you're in Canada. And it works fine for small curved panels like this. For bigger panels like door skins and stuff, it doesn't really work as well. But again, if you're determined enough, you can do anything with simple tools. I find with this type of work, patience is the key. I get a lot better results if I don't worry about how long it's taking. I just think about what I'm trying to achieve, and then I just work at it until I achieve that goal. And here's Poe again. She's being a little bit sassy. And now we're back to the English wheel. And this was just a lot of back and forth and rechecking to our template. And we're not in a rush. We're just working through it. And I did find that it was still a little underdeveloped in certain areas. So I just used the sandbag and mallet to put some more bumps in it. This is just a little bit more efficient than trying to stretch it with the English wheel forever. Then we went back and smoothed out those lumps and back and forth until we were finally felt we were starting to get somewhere. At some point during this process, I switched to a slightly lower crown die on the English wheel, and I just used that for the final smoothing of the panel. The high crown dies, they put shape in very quickly, but they don't leave a very smooth surface. So then we have to step it down to those finer lower crown dies to help blend things together. And now here is Alan. He's playing with some kind of a toy and seems to be quite entertained. And now we are bead rolling the body line into this panel, and we're just using our cheap garbage bead roller, which kind of gets the job done, I guess. And now I'm going to tip the edge of the panel over just using this piece of hardened steel thing with a slot cut in it. Nothing too crazy there, and we just go over and tip just a little bit at a time and work our way across the panel and back and forth and whatever. Better to do a little at a time than try to fold the edge over the full 90 degrees all at once. Once we get it tipped over, then we finish it off just with a hammer and dolly. Alrighty, well, here's where we left off about a year and a half ago with the panel completed. Now we're going to jump in our little time machine and we're going to head to about 3 months ago and pick up the pieces from there. There was a little confusion as to why I'm replacing this section of the fender in the last video, so I thought we'd just clarify that. So this is the inside, and what's happened, this is pretty common on these old 1930s vehicles, is the fender in the past cracked multiple times, as we can see here, and it's been welded and cracked and welded and cracked again. It's had chunks welded on here, and there's more cracks and welds than there is actually good metal under here, so that is why we have to replace this section. So a lot of these old fenders on these vehicles, they have a piece of rod that's actually rolled into the edge of the fender for reinforcement. So what we've done here is we have this piece of rod, the same diameter as what's in the fender, and we just kind of bent it to the shape that we need. And what we're going to do here is actually kind of an offset joint. So the patch panel is going to be joined in here, but the reinforcement rod is going to be getting joined in here. So that way we don't have our welds in the same spot, and it'll give a little bit of extra strength when we go to put this all back together. So got this rod welded in here, and I really like using the TIG welder for this. I just find it works a lot better. You can actually burn it in all the way, make sure it's fully penetrated all the way through. Thing is, you can use the MIG for this, but if I'm doing that, I'll try to like V out the edge or just crank up the welder so it welds hotter just to make sure I got it burned in all the way. What can happen a lot with the MIG is you'll end up just putting a weld on top, and as soon as you grind that weld away, then there's not actually anything holding the thing together, or it's not penetrated in all the way, and it can crack later on. So just something to keep in mind. And the other thing is you do want to make sure that you actually grind this back and have it smooth and flush, because if there's any weld protruding out or if it's chunky and lumpy, what will happen is when you go to put the outer skin on and hem this edge, you'll end up with a high spot poking through, and then you have to try and bodywork your way around a high spot, and it just makes a bunch of extra work and hassle. Okay, so what's happened here is I set the patch in place and I ended up having to do some fan dangling to get everything kind of right again. I think if you saw when I cut out the old piece, it did spring a little bit. And even though I do have a brace running in here to the end there, way back there, it's kind of all holding this in place, but it did kind of sag down here, so now I've just got kind of something clamped in here to prop it up. So it is important to kind of keep an eye on things like that, because these do tend to flop around, obviously, when you cut out half of them. Can't imagine why, but good demonstration on why it's important to kind of mark out where your patch panel sits before you cut anything out. And that way we have a reference point. We knew that it had moved and we were able to get it kind of jacked up back into where it needs to be. Otherwise, if we didn't do that, then we'd have to go to the other fender, which is quite difficult to access right now. We'd have to get in there and make a template of that, and then transfer it over to here and get everything lined up again, which is just a big hassle. Whereas, tacking something in here and making a couple marks on the panel where the patch was only took us, less than 5 minutes, and we're back where we need to be. And what I done now is, when I had the patch in place and happy with how it fit, I stand back and I look at how everything flows together from this angle, from this angle, from that angle, from that angle, from that angle, all the angles. Yep. And then I just scribe right along the edge of where that patch is. I don't know if you can see that or not. There's a line scribed here, and I'm not going to scribe the whole thing. What I'm going to do is I'm going to get it fitting in this area first, because that's going to affect the way that it fits into the rest of this. Once I get this area fitting to where I'm happy, then we can reclamp it on and rescribe more of it, and we'll just kind of continue to work at that. I'll show as we go. How about that? That rhymed. Cool. Neat. Here's the line that we're going to cut to, all scribed in there. So now we're finally ready to start tack welding the panel in, and I find this process takes a lot longer than the actual welding does, just getting everything fitting up the best that we can, but it is worth the extra effort in the long run. And again, I apologize for the camera work. It's like we somehow managed to always place the camera in a spot where the view was completely obliterated for this one. Don't worry though, the old camera crew has been fired and replaced with a slightly less alcoholic group. So for this wire hemmed edge here, there's like a special formula for calculating how much you need here. I'm not good at math, so I just kind of guessed and did a couple test pieces. But yeah, there's like all kinds of special tools you can build for this and whatever. But I'm just gonna wing it and see what happens. And that's just kind of what we're going for there. Just fold that edge over, just like doing a door skin. Just tap a little at a time, work your way through. Some people have made like special pliers I've seen for crimping it over, because it is kind of, you don't want to like smash this with the hammer when you're trying to fold it that last little bit. But I don't know, seemed to work okay, and I don't worry about getting stuff like this perfect, just as long as the rod is in there tight, which it seems to be. And it gives a surprising amount of strength to this fender. Like, it really stiffens up that edge. If you look at the way the factory did it, and you can see it is far from perfect. So if the factory didn't care, then I don't care. Even if the factory did care, I still wouldn't care, but you know, whatever, certainly good enough. So you can see I've got this all tack welded in as well now. I just kind of put a tack weld every ½ inch or so, give or take, just make sure both sides of the metal are kind of flushed up, so one side isn't higher than the other. And try to keep the tacks as small as possible. If I can just fusion tack them, I do that. Sometimes you have to add a little bit of filler rod, I find. But the fusion tack, it contracts less, or it seems to anyways, just because it's less heat, obviously. So you don't have to worry about as much about going in and hammer and dollying to stretch those tacks. Sometimes as you're going, it'll start to pull your seam together, and it'll start to kind of want to overlap or not do what you want. So you have to go in and just planish out, stretch out these tack welds. As soon as you hit it, usually it only takes a couple hits and it spreads back out, and then your gap will open back up and you can get a nice fitment there. So before I weld this in, I like to just spend a few minutes just kind of standing back and looking at it, making sure it all kind of fits together nicely, everything flows together, there's nothing weird going on, because it doesn't take much, you know, a little bit this way or this way, and it starts not fitting together right. So once we're happy with that, we can start our welding, and we can see here that all the time we spent getting things to fit paid off. Really decent fitment all the way through here. No big gaps or anything that we're going to have to weld, so this will be very easy to weld. The more time we spend fitting, the less time we have to spend welding, the less time we have to spend finishing out this panel and hammer and dollying and all that stuff afterwards. So it certainly pays off to fit everything, because the fitting part doesn't take a whole lot of skill. It's just tedious. The welding, well, that's a little bit more difficult. Hammer and dolly work, that's a little bit more difficult. So the easier we can make it for ourselves by just spending time doing the grunt work, the less challenging it is. If we had big gaps and stuff, this is going to be very tricky to weld, and we're not going to get as nice of a finished product. So the way I'm going to weld this is going to freak some people out, and it always seems to freak people out, but we're going to more or less weld this in one continuous pass. I am going to do this one a little bit differently. What I'm going to do is I'm going to do one side down here and then one side down here. And just the reason for that is just to make it more comfortable for myself. Personally, I just don't like trying to go uphill on sheet metal like this. I end up, with a less consistent weld. So if I start in the middle here, work downhill, start in the middle here, work downhill, it's just a little bit easier for me. I'm not an expert TIG welder, so I can't, moderate the heat as well if I'm going, two different directions and whatever. That is going to end up leaving us with a weird kind of lump in the middle, most likely, and we're also probably going to have some stuff going on here, and it's going to warp, and that's okay. We'll be able to fix all these problems fairly easily. There it is welded in, and I just knocked the heads of the weld off, and just like we anticipated here in the middle where I started and stopped is where the most warpage is. You can see we've got a dip here and in the corners as well. So this is pretty typical. A low spot in the corners and where we start and stop. It's actually fairly minimal warpage, all things considered, but these round panels usually hold their shape fairly well. Everywhere you see this blue around the weld, that's been affected by the heat, and so that means that this weld area has shrunk, and that's going to happen no matter how it's welded or what process is used. It's inevitable that it's going to shrink and pull in or out one way or the other, and it's going to have to be stretched to correct all of that. We could have avoided this spot in the middle. We could have flipped the panel on its side and welded it, or I could get better at welding. That would always be an option, so that I could do an uphill pass without adding too much heat to it or whatever. Lots of different scenarios there, but at the end of the day, I'm not too worried about it. This will be fairly easy to correct, in my opinion. And for me, I've done every different type of convoluted method for welding in a panel, all the tips and tricks and nonsense, sprinkling fairy dust on it and all this garbage. And I just find that with TIG welding, this is the fastest and most efficient way, and also the best way for me to get the job done. When I first started TIG welding, I was afraid to do a full pass. That's pretty intimidating, because I was used to MIG welding, and MIG welding, that's the last thing you want to do, is do a complete full pass, because it's it's going to warp quite badly, and it's going to be just about impossible to get straight again. I started out by TIG welding panels like I would with a MIG, just doing short little passes, letting it cool. And what I was finding is it was actually warping more. And so I was like, what the heck is this? And then when I finally got the confidence to just go for it, let it do its thing, I found that I was actually getting less warpage and distortion by just doing one continuous pass. I don't have to worry about pinholes or hot and cold spots on the weld. It just made everything so much easier. It's like it was a game changer for me. One of the huge benefits of TIG welding for me was when I discovered, I can weld something fast like this, have it warp, fix the warpage, and have a superior final product over a MIG welded seam that would take me, almost all day to do and grind down and mess around with, and still not have the nice results that I would get with a TIG weld. So at this point I was getting pretty lazy and kind of tired of working on this. So I wasn't totally happy with the profile of the bead on the body line we put in with our cheap bead roller. What just didn't quite match the original. So I decided rather than hammer and dulling the snot out of it and trying to work it out that way, I would just cheat and use some product on it. So here we are hammering the product on. So there's the completed repair if the camera will quit mucking about here. And it's definitely not perfect. I just kind of in the mode of just kind of getting things done, I think, at this stage. Not trying to get too carried away with making things absolutely flawless, especially considering the truck that it's going on. So it'll be fine, I think. Someone will probably disagree, but it's not their truck, so too bad. So next step for this truck is to yank the front sheet metal off. I think I'm just going to put the front fenders in epoxy primer for now. I'd eventually like to get them color matched to the rest of the truck, the green that's on it. But I think just, you know, for the time being, I think I'm just going to run them in primer and focus on getting the truck roadworthy. And once we get it roadworthy and all the bugs worked out, then we can spot in the fenders and do all that kind of work, all the fancy detail work. Does mean we have to pull it apart again, but you know, I just don't want to like scratch the snot out of it while we're doing other things, even though I guess it doesn't matter if it's scratched considering the rest of the truck, but I think you get the idea. Then I got to start fitting an engine into it. So I have this full pressure 235 that's been sitting here forever. So I think the plan right now is to see if I can get this engine to run. I got some manifold gaskets for it finally and some other little trinkets so we can get it running. And if it runs decent and has okay compression and whatever, I don't know the condition of it. I know it turned over, but that's about it. If we can get to run halfway decent, then we'll be putting this in the truck. Like I said earlier in the other video there, I have to get a run stand built so we can get this 216 running for the other truck. So I think once I have that stand out, we'll just plop this engine in, see if we can get it going. So that'll be happening this summer. I'm kind of trying to get things cleared out a little better in here for winter because there's just way too much junk hoarded away in here. So if I can get two engines running and put in the vehicles that they're going in, then that's two engines out of my way. That's a bunch of extra space cleared out. And if these engines are junk, I don't even know if they run. I know they both turned over, but they might be junk. So if they end up being junk, then we can get rid of them. Either way, it's a win. If the 6-cylinder ends up being junk, there is another option, or I guess path I can go as far as an engine for this truck. We're not trying to keep it like totally original because this is actually 3 different trucks pieced together. So it's not like some rare, you know, barn find survivor. It's just a bunch of junk thrown together. So I can do whatever I want with it because, again, it's my truck. And, you know, we're not wrecking anything that isn't already wrecked. So that being said, we're not, you know, chopping the top. We're not doing any of that crap. It is staying stock appearing, and we're not putting any modern crap into it. I don't do that. So we'll still have drum brakes and we'll still have bi-supply tires. If I do hop it up a little bit, it will be getting done in a way that's kind of sympathetic to the era of the truck. I didn't say no modern crap, but if we do go with the 6-cylinder, the plan is to run a T5 transmission. As some of you know, I put a T5 in my 66 GMC last year, and it's one of those things that just completely changed the drivability of the truck. Suddenly I can actually go on the highway with it now, and so that's kind of handy, and it's something that's not really visible unless you're crawling underneath the truck. Nobody's going to know. So plus I already have one. It does need to be rebuilt, but it's already here. So that's kind of the plan, is to kind of see if I can put this truck together with just the junk that I already have laying around, just to clear out some junk and just to get it on the road. And then if I decide to change or do whatever with it later, well, it's now a running, driving vehicle. There's a lot more motivation to get a functional vehicle back on the road than one that's just like this, which is just a pile of parts right now. So yeah, we're going to try for a 235 with a T5. Now, unfortunately, we are still missing one major piece of the puzzle, and that's the rear differential. Oh, look at all the birds. Nice nature moment. I do have this 53 Chevy Truck torque tube rear end out of the chicken truck, and so apparently what you can do is you can actually take this center section out, and the center section from 55 to 62 Chevy Truck will plug in. That'll give you the open drive, which we need for the T5, and then we've got the right width rear end, 6-bolt wheels, and all that stuff. So that's kind of what I'm thinking, is using this. Now, before you panic, don't worry, we are still working on the chicken truck. Just trying to keep busy here. It's good to be busy, busy. So we got lots going on, but we are still working on the chicken truck. Next week, or next video, we will be finishing up the quarter panel splice for the other side, and then we can start kind of hammering this thing together, mocking it up, and figuring out where everything has to be, and continuing cutting, welding, and all that fun stuff. And not that anybody cares, but parts for this blue car have been trickling in, and so I think they'll all be here by the end of the month. And so I still have to get this on the road this summer as well. So for the 2 people that care, this will be going on the road as well. So as always, thank you ever so much for watching, everyone. And big shout out to all the patrons of the show and all the people sending in wonderful donations. And thanks for all the likes and nice comments and negative comments or whatever you want to do. I appreciate all of you. So we'll see you on the next one.